This lesson is just really naming compounds. So the way I went about this was I didn't like using the common name. I think the systematic name was way easier, as we see here. So let's start by drawing the butane. So like in the previous lesson, if you watch the video, whenever it has a 2, that's where the double bond is. So going from 2 to 3. So I'm going to do a double bond from this carbon to this carbon. And then I see di, so I know there's going to be two groups that have the 2 oxygens, dioic. So I'm going to put an oxygen, 2 of them over here, and 2 of them over here. So I'm going to do 1 double bonded, and then 1 single bonded, and then 1 double bonded on the left, and a single bond. I'm going to add my hydrogens and hit arrange. And I see that it's E, so E means trans. So I'm going to make sure that the highest priority is on the opposite side. And here it's easy to see because hydrogen is going to be the lowest priority, so opposite sides. And for this homework, like he said in his video, just have a notebook and write down the different names. I think the other name for this is just trans-but-2 and butene dioic acid. And then Google is going to be our best friend on this homework. I had to Google a lot of the simple names. The systematic names are easy, but it's the other ones that are kind of confusing. So I'm going to draw my 6 carbon chain. 1, 2, 3, 4, 5, 6. Di again, so I know I'm going to have that same 2 different O double bond right here, and then a single bond on each side. So I'll go ahead and do my double bonded oxygen and my single bond on the left side, and do the same thing for my right end. Add my hydrogens and hit arrange. Okay. So again, these drawing ones aren't too bad when they're given systematic names. Again, we have the systematic name. So I'm going to draw my ethane, and there's no di on there, so there's only one set of oxygen molecules. So I have my double bonded oxygen and my single bonded only on one side. If it had di in the name, then it would be on both sides. And I believe this is also called, let's see if I can find it in my notes. I think it was like acetic acid or something like that. Some of them I didn't bother to write down because I thought I would remember them, but yeah. So hydroxy benzoic, so I'm going to draw my benzene ring for that benzoic acid. And I know there's going to be a carbon attached here that has the OH groups. So O double bonded, and then my OH. And then there's an O, so that means it's only going to be 1 bond away, my other oxygen, or my hydroxy group. Add my hydrogens and hit arrange. So hydroxy gives indication there's an OH group, and this O indicates that it's 1 bond away from this carboxylic group. Had it been M, then it would be 2 bonds away, so it would be attached here. And had it been P, it'd be on this one, 3 bonds away. I think P stands for para, and then this one's meta, and this is ortho. And lastly, I actually forgot to do my double bonds, so I'm going to undo that and do my double bonds. I'll do one here, here, and over here. Add my hydrogens. So yeah, with these, you just gotta double check. Sometimes I forget things, and I usually triple check to make sure that it's right. And for the cyclic pi electrons, we're going to just put 6 because we count 1, 2, 3, 4, 5, 6. Oxalic. Okay, so this is one of the common names, and those are the ones that really kind of confuse me. So I did a lot of Googling, but basically this is just ethanedioic acid. So I'm going to do my 2-carbon chain, add my oxygens on both sides. I'm going to go ahead and delete one because I did it wrong. Okay, so oxalic acid is just ethanedioic acid. Add my hydrogens and hit arrange. Make sure everything looks good. Yep. It doesn't matter where you have your oxygens on either side because there's no double bond here. So you don't have to worry about priorities or anything. It's only when you have a double bond that you have to worry about which priority is greater on each side. Okay, so here's a good systematic name. I'm going to start by drawing my butane. And I see a double bond on the 2. So I did my double bond right here. That indicates that I'm going to have that, what I was just talking about, I'm going to have to do the priorities because it's C. And lastly, Dionic acid. So I'm going to have my oxygens, a double bonded oxygen and a single bonded on 1 carbon. And the opposite, I'm going to do the same thing, double bonded oxygen and a single bonded oxygen. Add my hydrogens and hit arrange, roll. And Z stands for same or same, however you want to say it. That's how I remember it. So they're all on the same side. So that's exactly what we needed. And if you're having trouble how to do that, you can just split this in half. And you just look at the highest priorities on this side. So I already know that hydrogen's my lowest priority on both sides. And these are my highest priorities. So this indicates that these are on the same side. See, 1 on 1 on top and 2 and 2 on bottom. If this was E, then I would need to switch these two to put 1 on bottom and 2 on top. So they would be diagonal of each other and opposite sides. Okay, so let's submit that and see if that's right. And again, you only have to check the priorities when you have a double bonded carbon like that. Okay, here's another systematic name. So I'm going to draw the butane to ene. So I got my double bond, and then this is exactly like the previous one, just a different name. So those will be the 2 names, cis or Z. Cis, same, that's how I remember it, as well as the other one. Same, it's all the same. Okay, so I do my 2 oxygens on each side, only 1 double bonded for each, and 1 single bonded for each. Add my hydrogens and hit arrange. Cis is the same as same. So it looks like I'm waiting for this to stop, but yes, so the highest priority is both on the bottom and my lowest on top. So same side, cis or Z. Okay, benzoic acid. This one is just a benzene ring. I'm going to add my double bonds now because I forgot last time. So I put a double bond here, I'll put one here, and right here. And I'm going to add a carbon. And my double bonded oxygen, and my single bonded oxygen. it's just benzoic acid. There's no O or M or P or anything like that, so, or hydroxy attached to it. So this is basically all it is. Just one carboxyl group at the end attached. So this is the end product. And then I have my 6 pi electrons because I count 1, 2, 3, 4, 5, 6. This one I just remember from the video I watched from his, and it's 4 with a, it's the same as the butanoic, butanoic acid. There we go. Butanoic acid. So no double bonds anywhere. Again, the systematic names are easier. See, we have the 1, 2, 3, 4 for butane, and then just 1, no di. So butanoic acid. And that's it. Acetic acid, I believe this was 5. Okay, no, so this was 4 carbon chain. And just like the butyric acid, it has this at the end, but the difference is that it has the carboxyl groups on both ends. So I'm going to add my hydrogens and hit arrange. So this was the same as this is the same as butane-dioic acid. The previous one, which is butanoic acid. So just make sure you have your 2 carboxylic groups on both sides. Okay, that was it. Let me see if it lets me go in again. Just to do some more problems. So this one we did already. I'll do it really quick. So I see the dioic acid. Oh, let me get my double bond on 2 going to 3. And my oxygens, 1 double bonded, 1 single bond. Cis, same side, so that's it. Pentanoic acid. So pentane, you're going to do your 5 carbons. And it ends in oic, not dioic, so I'm only going to have 1 carboxylic acid on one side. So add my hydrogens and hit arrange. So this is the end product. I believe this is also called valeric acid for the common name. Okay, so when you're writing the name, you just start off with the longest carbon chain. So 1, 2, 3, 4, 5, 6. Hexane. And I'm gonna have oic acid. If I had the dioic, I could add the E, but I don't, so I'm gonna leave it like that, like this. And then I believe this is also called caproic acid. So I could also enter it like this, caproic acid. But I like the systematic names better. It's just way easier. Okay, we're doing the naming again. I see ethane. Ethane. I'm not going to add the E because there's no D, because it would sound really weird if it was like ethanoic, you know, so it's ethanoic acid. If it was di, then you could add the E, again like that previous one. Nice, this one's just naming so far. So, longest carbon chain, 1, 2, 3, 4. Butane, I will add the E because I see that there's two sides. So dioic acid. I don't see any double bonds, so I don't have to add anything here. Butane dioic. Yeah, should be good. So when you have your double bond, it would be butene. But there's no double bond in the carbon chain, so we can leave it as is. 1, 2, 3, 4. Butanoic acid, because there's only one part that has a carboxylic acid. No double bonds or anything, so that should be it. I didn't add the E, of course, because it would be too many vowels. Pentane dioic, so 1, 2, 3, 4, 5, and then it says di, so I'm gonna have my 2 oxygen on each side. And it doesn't indicate that there's any double bonds, so I can leave it as is. Okay, so hydroxy benzoic acid. How I was saying last time with the benzoic acid, it was just a simple, I only had this attached, but since I have a hydroxy, I know there's going to be an oxygen at the 2 position. So I'm going to put my carboxylic first. And then I'm going to add my hydroxy group. And I'm also going to do my double bonds. I put one here, I'll put one right here, and another one over here. Add my hydrogens and hit arrange. And of course, this would also be the same as if it had O instead of 2, or ortho. Again, we're going to put 6 because we count here 1, 2, 3, 4, 5, 6. We don't count this one. Okay, so longest carbon chain, 1, 2, 3, 4, 5, 6. Hexane, and I can put the E because I see that there we have 2 oxygens on each side. So hexane dioic acid. No double bonds within the carbon chain, so this is a simple one. And again, Googling on this homework is one of the key things to do when you get started. It'll really help out, and especially when you go to like pubchem.com. Oh, pubchem.com, it shows just everything, and it's amazing. It shows a 3D model, and it's so easy. So butane, I'm not going to put the E because there's only one side with the oxygen groups. So I'm going to put my oic acid. And you can also do the butyric acid, and you'll get the same thing. So I'll put that one. Hopefully I spelled it right. So yeah, I just recommend Googling the common names, and that'll really help out. But yeah, good luck.